We have our lightning talks now. So we have a few 7, 8-minute talks coming up. First one is Kennedy Sanagi, which you heard from earlier. He's going to tell us about software and data engineering approaches for managing digital public goods, scientific data, and the case of ISIPE. Okay, so we already heard about many of the things that, please come, many of the things that he's worked on. This will go into a little bit more detail. So if we can bring up the slides, please.
Thank you. Hello, everyone. I think this is not the best time to make this presentation. Yeah. I know you're tired. It's the last day. Yeah, it's an afternoon. But I hope you've taken enough coffee to make you alert. So I'll talk about software and data engineering approaches for managing scientific data. Then we'll look at a case study of ISIPE. So I'll give some perspective of who we are as ISIPE. So ISIPE, we were founded in 1971. We are now more than 50 years old in terms of after being founded. We have more than 500 staff, recruited both internationally and locally. We are based in Kenya, in Nairobi. Yeah. We also have branches in Kenya, including Mbita, that's the western part of Kenya, some in the southern part of Kenya. So we have some bits of branches in Kenya. We also have a branch in Ethiopia, housed in Ilri. We also have a station in Uganda and Benin. So our activities cut across Africa. Our main core business is insect science. I don't know why this one is not showing up. It would have been easy for me. So our main business is insect science and related domains within insects. So we look at how insects affect human. Yeah. For example, mosquitoes transmit malaria. We're looking at how insects affect animals, like the tsetse fly causing trypanosomiasis, how they affect the environment, for example, the desert locusts, the ravaged environment. We look at how they affect plants, like at the caterpillars that eat plants and such, the fall armyworm eat plants. So all these is looked under one umbrella called the One Health. Our core mandate is to develop extended tools for management of these insects as we preserve the natural resources. So we want to manage the insects at the same time not affecting the environment where they live in and other organisms within there. For example, we are fond of spraying pesticides, not knowing that these pesticides, yes, they kill that pest, but also affect other pests, like the pollinators, like the bees. And when the bees die, that means there's no pollination. That translates to low productivity. So in the context of this summit, I'll just take you through the activities that most, if not all, scientists do at ISIPE that is really related to this summit. So to begin with, all scientists must write grant proposals. Start from there. So these grant proposals mostly are public funded by governments or well-wishers or any other organization. So most science is data-driven, so we must go to the field and collect data, whichever, it could be household data and insects-related data and all that. Then after collection, then this data must be analyzed, where we draw different kinds of scientific findings from that data. Some are quite innovative and they really take us to the global map in terms of science. After analysis, then what? This information must be disseminated in terms of the tools that I'd mentioned before, like the integrated past management approaches for managing the fall armyworm, and many other tools should be disseminated to the public. Some are digital public goods, and some are theories that can be upscaled for adoption. Then, that data should not be thrown away, it should be archived. So that takes us to the digital public goods again. And what's the purpose of that? It should be reusable to the public, so that not really the public needs to reuse this data and extend science out of it, or develop more innovative products. So those are the activities in terms of data that we're highly involved in as an organization. Besides that, there is pressure from donors who give us money. Some of them make it very clear that you need to show how you manage your data, all the way from data collection to archiving this data. That should be very clear. So some donors say that, some don't say that. I know this room have some few donors. I think that Klaus is one that you highly relate to. And some donors say that you should show how this data will be reusable at the end of the day. So the organization was put into a situation whereby we really need to come up with digital tools for managing data, and to align that to the universal standards of data management. So we, in just about 2008, the institution passed a policy called the Research Data Management and Archival Policy. It talks about how the institution should manage its scientific data. It's from there that some of us were lucky, like me, I was recruited because of that policy. So, and one of the tasks was to build the software and data engineering pipelines for managing scientific data for the institution. As a scientist, we are really interested in looking at the literature, what has been done, what has not been done, and how to improve that, and maybe how to build and come up with a better system. So this is one of the papers that really inspired these works, where it says, behind every great research project is great data management. So I'll not take you through that. So that led to a development of this robust data management pipeline that you see here. I'll just take a few minutes to expound on this, because this is very, very important. So as you see in black on the far left, there is what we call the common ontologies. I totally agree with many of you who say that the first thing is to have the ontologies well laid out. And these ontologies are just variables that make this data common in a way. Yeah. So these ontologies are adopted in what we call the data management plan. Some donors require that before you submit a proposal, you must submit a proposal with a data management plan. So that's why it's necessary to point it down so that some variables are fetched there and plugged into a DMP when writing a grant proposal. From the black, you go to, I think that's orange, where at the top you can see some API and scripts that fetch data from the cloud. So we are saying that these ontologies should be fused with data that is getting into the system, yeah, including data from a Google engine, for example, temperature, rainfall, all those variables should be fused with the common ontologies. Then below that, you can see the metadata holding legacy data. So there's a component of us not looking at the ongoing projects and related data, but also looking at the historical data. That's the legacy data, because you've been existing for more than 50 years. So how are you able to manage that legacy data? So again, we are saying, when the legacy data streams in, when scientists willingly give their historical data, then that must be fused with the common ontologies. And then down there, you can see the digital data collection tools, including REDCap, ORDK, and COBOL. So we have all those in place for our scientists to use in data collection. So when defining a variable in ODK, then you must fuse that with the common ontologies. Yeah. So after looking at these data that is coming in, it streams into all the way into the data warehouse, but it goes through the ETL process whenever necessary. So in the data warehouse is where now this data gets archived. So it's archived there after the scientists have maximally utilized that data. But we are projecting that we also need to build what we call the data lake. And under the data lake, users are given different rights to access each piece of data. And then it's from there now that should be archived in the data warehouse. And our policies say that data in the data warehouse should be there for at least 10 years. So you can see it's open or locked. So the red means not public. The green one means it's in the public. And the public can reuse that piece of data or extend it in different ways. So out of this, we wrote a paper, and it's published. So this paper explains the pipelines that I've just explained in the previous slide. So we are lucky that it was published last week. Yeah. And these infrastructure, they're live, they're in the public domain, so you can access them through those links. And these are our donors who facilitate our scientific activities in ISIPE. That's all.